Hello class, this is a video tutorial on further descriptions of quadratics. In this video, we'll be looking at rational and irrational roots. Previously, we've seen that if the discriminant is greater than 0, it shows that two roots exist. It can now also be determined if the roots will be rational or irrational roots. The extra detail we should pay attention to now is if the discriminant delta is equal to this form, p on q all squared, where p and q are some integers. And if it is some form of p on q all squared, it will be a rational root or rational roots. And if it isn't, we will get irrational roots. A quick demonstration of this is, let's say we calculate the discriminant and it comes out as delta equals, let's say, 16 on 36. Notice how this is of the form 4 on 6 squared. This, if delta is equal to something like this, that will be a rational root. And the simple reason for that is delta sits underneath the square roots b squared minus 4ac. And because we are square rooting something that looks like this, it will come out to a rational number. So in this example, if we have, say, square root 16 on 36, it comes out as 4 on 6. Notice how if this is the result we get, the roots will be rational. If it isn't this, so for example, let's say it was 13 on 4, if we place this under the square root of the quadratic formula, we will get square root 13 on 4, which will result in plus minus square root 13 on 2. Notice how square root 13 is an irrational number, giving us an irrational root. Seeing all this, let's actually put this in action by sketching these two parabola. So let's approach this slightly differently. Normally, we would try and factor and find the x-intercepts first. But for this, let's use the discriminant. So for this, delta equals b squared minus 4ac. That will be negative 1 squared minus 4 times 2 times negative 3. Plugging this into your calculator, we get negative 1 squared minus 4 times 2 times negative 3. Comes out as 25. Now notice, because delta is a perfect square, it is of this form, that will give us a rational root. So now let's do this using the quadratic formula now. So negative b, so minus 1, it's positive 1, plus minus square root. And remember, delta sits underneath this square root. We've already calculated it to be 25. So placing 25 here, all over 2a, so 2 times 2 is 4. Notice how we get the square root of 25 is 5. So we get x equals 1 plus minus 5 on 4, which when we solve this, we get 1 minus 5 on 4 and 1 plus 5 on 4. We get two nice decimal roots or rational roots. We get negative 1 and 1.5, which as an x-coordinate, we get negative 1, 0, and 1.5, 0. So notice how when the discriminant delta is a perfect square, so of this form, we get two rational x-intercepts or roots. Because we need to sketch this, we also need the vertex and the y-intercept, but that is not the focus of this video. I'll let you pause and quickly calculate the vertex and the y-intercept. The y-intercept is very easy. It's shown right here. But for the the vertex, hope you can recall that we need to use the axis of symmetry, negative b on 2a, and then we substitute what we find, 1/4, back into these x values, and it gives us the y value for the vertex. Using these points now, so let's take a look now at our roots, -1 and 1.5. So -1 is here, 1.5 is here. Our y-intercept is -3. This one's a little tricky to sketch. 1/4, -3.25. Well, if a half is here, a quarter is halfway, and -3.125 is half of the quarter. So it'd be something like this. So plotting all of these points, we get -1, 0, 1.50, we get 0, -3, and I'm going to put this as a decimal, a quarter, comma, -3.125. Bringing all these points together, our parabola should look somewhat like this. Okay, so once again, notice how in this example, when delta is a perfect square, we get two rational x-intercepts. Let's now do it for this next parabola. Once again, let's approach this slightly differently, and let's find delta first. So delta, so the discriminant is b squared, 6 squared minus 4 times -1 times 11 into our calculator. 6 squared minus 4 times -1 times 11 times 11, we get 80. So now when we put this, and notice how 80 is not a perfect square, it is not of this form. So it is not of this form. We are going to get irrational roots. So now let's place this into the actual quadratic formula. X equals -b, -6, plus minus square root of 80 all over 2a. 2 times -1 is -2. Square root of 80, we have to simplify in simplest form as a surd. I've already tested this previously. It's 80 divided 16. So we will get root 16 times root 5. So remember, it'll be root 16 times root 5. That will be root 80. But that simplifies down to 4 root 5. So this becomes -6 plus minus 4 root 5 all over -2. And simplifying this even further, between -6 and 4, I can factor out -2 outside of +3 plus minus 2 root 5 all over -2. And the -2's will cancel, leaving us with 2 roots. So the roots that we get, because this is in simplified surd form, we get 3 minus 2 root 5, comma 0. That's the first x-intercept. And emphasizing again, that is an irrational number. And the other is 3 plus 2 root 5, comma 0. So notice that when the discriminant is not a perfect square, we get 2 irrational roots. Now, we are almost finished with sketching this parabola, but once again, you need the vertex and the y-intercept. I'm going to pause here so you can sketch it yourself. And then from here, we can simply find the y-intercept and the vertex. And using all of these points, we can plot everything together, and we get Uh, let's plot these points, 3, 20, and 0, 11 first. So 0, 11, 2, 3 is here, 20. But now when it comes to finding these x-intercepts, the only thing that we can do here is an approximation. So taking a look at what these values are, so 3 minus 2 root 5 and 3 plus 2 root 5, we actually get negative 1.47, approximately negative 1.5. So I made these go up in twos. So 1 would be here. So 1.5 is about here. And 7.47 is approximately 7.5. 2, 4, 6. So 2, 4, 6. And 7.5 is approximately here. Plotting all of these points, making my parabola, extending it out, we get a parabola that looks like this. So these points are now 3 minus 2 root 5, 0. 3 plus 2 root 5, 0. Our y-intercept was 0, 11. And our vertex was 3, 20. So notice how we can still plot, well, hang on. Notice how when the discriminant shows it is not a perfect square, we will get 2 irrational roots. And when we go about sketching these, we need to take the closest approximation we can to when we sketch them. So I hope this has given you an insight into how the discriminant can show whether the roots are rational or irrational. Hope to see you in the next video, and best of luck.